Science meets adventure. Why do rivers curve like snakes instead of taking the shortest route? If water wants to get downhill, wouldn't a straight line be the fastest, easiest answer? But here's the twist. Rivers don't choose their path like a person with a map. They're sculpted by physics, speed, friction, gravity, and the ground beneath them. And once you understand that, you'll start seeing rivers differently on every hike and road trip. You'll pick better viewpoints, take smarter photos, and avoid some surprisingly dangerous spots near the water's edge. Imagine you're standing on a cliff or a high bridge, looking down at a wide floodplain. The river below isn't a single line. It's a ribbon looping back and forth in smooth S-shapes. The surface catches the sky like a mirror. On one side of a bend, the bank looks steep and raw, like it's been bitten away. On the other side, there's a gentle sandy curve, maybe even a little beach. That scene isn't random. It's the river writing its story, one bend at a time. Here's the core idea in plain words. Fast water has more power to wear things away, and slow water tends to drop what it's carrying. When a river wears away its bank, that's erosion. Think of it as the river scraping and chewing at the land. When a river slows down and drops sand or mud, that's deposition, like the river setting down its backpack. Now the question becomes, why would water be fast on one side of a bend and slow on the other? Picture the river entering a curve. The main current, called the thalweg, which simply means the fastest, deepest line of flow, gets pushed toward the outside of the bend. The outside becomes deeper because fast water scours the bottom and the bank. Deeper water tends to flow faster, and faster water tends to dig deeper. It's a feedback loop. That outside bank is called a cut bank because it gets cut away. It's often steep, undercut, and unstable, like a shelf that can collapse without warning. Meanwhile, on the inside of the curve, the water is shallower and slower. Slower water can't carry as much sediment, so it starts dropping sand and mud. Over time, it builds a gentle mound called a point bar, the sandy inner curve you can sometimes walk on. If you want an analogy, think of a racetrack. On a curve, the fastest cars cling to the outer lane because they're carrying speed and momentum. In a river, the fastest flow hugs the outside bend for the same reason. It's harder for moving water to change direction. And just like a racetrack gets worn in the high-speed lane, the outside bank gets worn by the high-speed current. So one simple rule explains a lot. Outside bend equals faster, deeper, more erosion. Inside bend equals slower, shallower, more deposition. But that's just how a bend behaves. The bigger question is how bends appear in the first place. A river rarely starts perfectly straight. A fallen tree nudges flow. A harder patch of soil resists erosion. A small slump of mud sticks out. A boulder deflects the current. Even tiny irregularities, little wiggles, can grow. Imagine pouring water down a long, slightly uneven sidewalk. The flow will find the easiest path around small bumps. Once the river starts bending around an obstacle, the physics of fast outside and slow inside kicks in, amplifying the bend. The outside erodes more, the inside builds more, and the curve becomes stronger. Over months, years, or longer, those meanders don't just sit there. They migrate. They migrate sideways. This is lateral migration, meaning the whole bend shifts toward the side where erosion is strongest. The cut bank retreats. The point bar grows. The channel moves across the floodplain like a slow, living creature. They also migrate downstream because erosion and deposition aren't perfectly balanced in place. The bend can walk along the valley like a wave sliding forward. And floods? Floods hit the fast forward button. During high water, the river carries more energy, more sediment, and can bite harder into its banks. A single flood can carve a fresh chunk from a cut bank, topple trees, and reshape the curve in days compared to the slow work of normal flow. Now for the payoff moment, the one that makes meanders feel like a plot twist. Oxbow lakes. Imagine a meander getting bigger and bigger until two bends nearly touch, separated by a narrow neck of land. From above, it looks like a looped ribbon with a pinch point. Then a big flood comes through. The river, impatient and powerful, takes the shortcut across the neck because it's steeper and faster. Suddenly, the old loop is abandoned. Sediment plugs the entrances. The main flow commits to the new straighter channel, and the looped section becomes a separate crescent-shaped lake. That's an Oxbow lake, basically a former river bend cut off from the main river. For explorers, Oxbow lakes are gold. They're calm water compared to the main current, often packed with life: birds, fish, amphibians, and thick vegetation. At sunrise or sunset, they can look like liquid glass, reflecting the sky with almost no ripples. If you've ever seen a perfect aerial photo of a river curve and a quiet crescent lake nearby, you were looking at river history frozen in place. But not all rivers meander much, and that's important for travel expectations. In steep mountains, rivers don't have time to wiggle. The slope is strong, the flow is fast, and the river tends to cut downward into the valley rather than sideways across a floodplain. You'll see straighter channels, rapids, and rocky beds. In confined valleys, where bedrock walls squeeze the river, the channel can't migrate sideways much. It's trapped. That's why canyon rivers often feel direct and intense, and sometimes you'll see braided rivers. Braided means the river splits into many shallow threads that split and rejoin, weaving around gravel bars. This usually happens when a river has lots of sediment and a wide, shallow valley floor, often near mountains where glaciers or landslides dump gravel into the system. Now, let's translate all this into practical travel value, because meanders aren't just pretty, they're information. If you want the best viewpoint, gain elevation. High ground turns a river into a map. Look for overlooks, ridgelines, and bridges that cross near a bend. If drones are legal where you are, meanders are one of the most dramatic patterns you can capture from above, but always respect local rules and wildlife. For safety, treat cut banks like unstable cliffs. That steep outside bend can collapse, especially after rain or during high water. If you see roots hanging in midair or fresh cracks in the soil, back up. Also watch for slippery mud near point bars. The inside bend may look friendly, but fine silt can behave like grease under your boots. Navigation-wise, river bends lie to your eyes. A campsite across the river might look close, but if the channel snakes, the actual walking distance can be much longer. When you plan a route, don't trust straight-line distance on a map. Follow the terrain. Seasonal changes matter. During low water, point bars appear like little beaches, and the river may look clearer. During high water, the channel spreads. The water turns brown with sediment, and the river can move faster than it looks. After a cool night, early morning can give you the cleanest reflections, calmer winds, smoother water, and that mirror-like surface you saw from the bridge. Wildlife loves the quieter zones. Point bars can attract birds looking for food along the waterline. Oxbow lakes are often hotspots: more shelter, calmer water, more plants. If you're a photographer, golden hour near an oxbow can feel like cheating. And wherever you go, keep it wild. Leave no trace isn't a slogan. It's how these places stay beautiful. Pack out trash, avoid trampling fragile banks, and don't carve new paths down muddy slopes that will erode even more. So how do rivers choose their path? Fast water erodes more. Slow water deposits more. The outside of a bend gets faster and cuts a steep bank. The inside slows down and builds a sandy bar. Small wiggles grow into big curves. Curves migrate. Sometimes they pinch off and leave oxbow lakes behind. It's physics, written in landscape. And once you see it, every river bend becomes a story you can read on your next adventure. Like, share, and subscribe to Science Meets Adventure.